In this video, I am going to explain how to plot standard test sequences in Matlab. Before going to that, let's see some introduction of Matlab. Matlab stands for Matrix Laboratory. It is a high-performance language that is used for technical computing. Getting started with Matlab, it is both programming language as well as programming environment. In Matlab, there are three windows. They are command window, editor script window, and workspace window. In command window, we can give our code directly and execute it without saving it. This will save our time for small and executable programs. In editor window, we can save our program with .m extension. Then we can run our program. This is useful for large programs. Workspace window. In this window, the values of the variables that are created in the program are displayed. Matlab has many inbuilt functions. With using these functions, we can find sine, cosine, and tangent, and also we can find inverse of a matrix, determinant of a matrix, cross product, and dot product. So, before going to Matlab, again we will see what are the sequences we have. First one is unit impulse sequence. Unit impulse sequence is a sequence in which only at 0 there is existence of the signal. The remaining points there is no signal. That's why the signal is represented as del of n is equal to 1 at n is equal to 0 and 0 at n not equal to 0. The next signal is unit step sequence. In unit step sequence, signal exists only when n greater than 0. That is, whenever n is greater than 0, the output is 1, like showing in the graph. When n is less than 0, the output is 0. So the expression is u of n is equal to 1 for n greater than 0 and 0 for n less than 0. The next signal is unit ramp sequence. Unit ramp sequence is a sequence at which when n greater than 0, our r of n is equal to n, like showing in the graph. At n is equal to 1, r of n is 1. At n is equal to 2, r of n is 2. At n is equal to 3, r of n is 3. So the expression is given as r of n is equal to n for n greater than 0 and r of n is equal to 0 for n less than 0. The next sequence is exponential sequence. Exponential is a sequence at which e of n is represented as e power a into n. The graph for the exponential sequence is shown in figure 4. From 0 to it will increase up to infinity like exponentially. That's why it is called exponential sequence. The next sequence is sinusoidal sequence. Sinusoidal sequence magnitude is represented by sine 2 pi n. N values increases from 0 to 360. The one cycle is continued. The last signal is cosinusoidal signal. The cosinusoidal sequence magnitude is cos 2 pi n. It is 90 degrees phase with sine. Now let's start programming in Matlab. Here it is the command window and here it is workspace window. Before going to plot, we need two things. To plot a graph, we need x-axis values and y-axis values. If you know x-axis values and y-axis values, then we can plot a graph easily. I already created a program that signal generation.m. So I will explain the program here. First of all, for unit impulse signal, we need x values and y values. Here x is considered as t. T values taken from minus 2 to plus 2 with step 1, and y values are considered as 2 zeros, 1 1 and 2 zeros. As we know that unit impulse response exists only at n is equal to 0, so we taken from minus 2 to 2. Minus values are minus 2 and minus 1, plus values are 1 and 2. In middle, origin is there. So 2 values are taken as 0 and 1 value has taken 1 and 2 values are again taken as 0. So x values and y values are ready. Now to plot a continuous graph, we will use this function plot of x comma y. But we are here using discrete values. So we are using stem of t comma y. Subplot is another function used to divide the figure into parts. Here I am totally explaining 6 graphs, So I divided subplot as 6. 2 comma 3 means 2 rows and 3 columns. Totally 2 rows and 3 columns are 6 parts. In that first part is this unit impulse signal. So I written it here, subplot of 2 comma 3 comma 1, and I am given the titles. Title unit impulse, and Y label is amplitude and X label is N. This is the program for generating unit impulse signal. And the next program is unit step signal. Here the input is given by taken as user. N is equal to input of enter the N value. Here the user will give the N value as 5, 10, 15, anything. Here we considering the X values, that means the T value as 0 to N minus 1 with step 1. As we know, the unit step signal always at N greater than 0, the signal is 1. So the Y1 is taken as once from 0 to N. So that's why the code here is Y1 is equal to once 1 comma N. Now in subplot of 2 comma 3 we are using the second graph. So here the written code as subplot of 2 comma 3 comma 2. Again stem is taken, so that we are using here discrete signal. The stem of X comma Y, here T comma Y1. Title has given unit step and Y label amplitude and X label N. Similarly we will do remaining programs. For ramp signal we need N input, taken as N1 is equal to enter the length of ramp sequence. T value taken from 0 to N1 with step 1. Subplot of, here we are considering the third graph, so that subplot of 2 comma 3 comma 3, and we taken stem of T comma T, because for ramp sequence X and Y are equal. So the stem of T comma T means X and Y both are T. That's why here it is taken like this. The title is ramp sequence, Y label is amplitude and X label is N. The next one is program for generation of exponential sequence. We already know that exponential sequence, the equation is e power into at. For e power at we need two values, a value and t value. To take t value, you are taking one input, that enter the length of exponential sequence. To take a value, again we are giving another input to enter the value. T value is taken from 0 to n2 with step 1, and this is the fourth graph. So subplot is 2 comma 3 comma 4, and we are drawing a discrete sequence. So stem of t comma y2, and title is given as exponential sequence, and y label is amplitude and x label is n. The next program is program to generate sine sequence. For sine sequence, the x value is taken from 0 to pi with step of 0.01, and y value is taken as sine 2 pi t. Already we know that the equation is for sine sequence is sine of 2 pi t, and it is the fifth graph. So subplot is taken as subplot of 2 comma 3 comma 5. Before 4 sequences we drawn the discrete sequence, so we taken stem, but here we are using continuous signal, so we taken plot of t comma y. Title is sine wave, y label is amplitude and x label is t. And the final program is program to generate cosine sequence. In cosine sequence also we taken t values from 0 to pi with a step of 0.01, and the equation is cos 2 pi t. Here the graph is sixth graph, so we are using subplot of 2 comma 3 comma 6, and we are using continuous sequence, so that plot of t comma z. Title is cos wave, y label is amplitude and x label is t. After typing all the program we need to save it, and after saving we need to run the program. While running the program, a figure window is popped up, and in that the graph will be shown. Before that graph we are asking the n value. In command window we need to give the inputs. So for their first unit impulse sequence there is no input, we are given directly the input. But for unit sequence we taken an input here, n is equal to enter the n value. So we need to enter the n value. Let's enter the 5. So the unit step sequence came from 0 to 4. The values are 1. And next it is asking the length of the ramp sequence as 5. So let's check in the output. So the length of the RAM sequence is 5, and let's give length of the exponential sequence as 10, and it is asking for a value. Let's give a value is 0.5, and the exponential sequences came. For sine wave and cos wave there is no inputs, so they directly came as output. So this is how to we plot the graphs in Matlab. We just need an x value and y value, and we will directly plot the graphs by using plot or by using stem. To find all the graphs in the same page, we will use subplot. If you don't need to use subplot, we can directly give the values to plot.